Hello everyone. In this video I'm going to look at the basics of the standard form for a circle. So given this equation, quantity x minus 3 squared plus y plus 5 squared equals 36, I want to use information from this equation to figure out the center and then the radius of the circle. What I want to use is I want to compare it to my general form for a circle, or I should say the standard form for a circle, which is x minus h quantity squared plus y minus k quantity squared equals r squared. Using this setup, we can line up what it is that we want. So for example, our x lines up with the x here, which means our 3 lines up with the h. And notice, since this matches up directly, this means I can say that the center of this circle is going to be, has an x value, I should say, of positive 3. Since, as I said, everything just matched up directly. X to x, minus minus, 3 to h. Now you notice over here for the y, because they have this, both x and y in the standard form are minuses, subtraction. What that means is it has kind of an opposite effect on things. In other words, since it's positive 5 here, y plus 5, that translates to a negative 5 as the center of the circle. Reason is, if I can rewrite this as y minus a negative 5. This way, it matches up to the original form, y to y, minus minus, which means k is negative 5. So when we go from the equation to the actual center, it has that opposite effect, and then vice versa. Looking over here now, we simply say that if r squared is equal to 36, by taking the square root we can say that r, the radius of the circle, is at 6. And when we take the square root, as you might imagine, we always want to use the positive value. Of course, we can't have negatives for distance, so it's never going to be r is plus or minus 6, it's always going to be just 6. Let's look at this example. Again, using my general form for reference. I can say that for my x and y, I just go with the opposite. So if it's positive 4 in the equation, it's negative 4 on the actual graph. Positive 1 here, negative 1 here. R squared is 121, so my radius is 11. Let's look at this example. Now, one of the big differences here is it's not x plus or minus anything. It's just x squared. The way we interpret that, it's the same thing then as saying x minus 0, or for that matter, we could say x plus 0. That means that our x value then is 0. The general rule is if it's x squared or y squared by itself, we interpret that as 0. Now, same as before, negative 3 here, so a positive 3 in my center. Now this time, when I take the square root of 50, it's not a perfect square. I want to reduce that to the square root of 25, square root of 2, which means my radius is now going to be 5 square root of 2. Finally, if I want to graph these, let me go back to my first one. If I want to sketch my graph, one of the simplest things I can do, and depending on your instructor or the course that you're in, it might be different, so just understand that. But a simple way of doing it is, of course, start with the center. So 3 to the right, 5 down, I'll say is right about here. I like to pick 4 points, the distance of the radius from that center, meaning that if I go up 6 units, that puts me here at 3, 1. If I go to the left 6 units, puts me over here about, that's -3, -5. And again, I'm getting -3 because if I'm going 3 to the left, there's going to be 6 to the left. That's the equivalent of subtracting 6 from 3 to get -3. Same thing for my first pointer. Going 6 up is the equivalent of adding 6 to -5, which is where I got a +1. Going 6 to the right now, with the space I have, that's going to be 9, -5. And then 6 down would put me here at 3, -11. Once I have these 4 points, it's going to be a matter of just connecting them in the form of a circle. So I'll connect it like so. And I have a fairly accurate circle. So these are the basics of the standard form for a circle.